Hello, my name is Francisco Garcia. This is my project. So, we have found Professor Fees dead on the floor in the classroom at 7:30 p.m. His body temperature at that time is 80 degrees Fahrenheit, which is 18.6 degrees below the average temperature, which is 98.6 degrees. At 8 p.m., 30 minutes later, or half an hour later, it is 75 degrees Fahrenheit. So, what time did he die? Well, the way that we're going to determine that is using Newton's law of cooling. So basically, we're going to use this equation. The temperature, which is the cooler temperature, is equal to the ambient temperature of the room plus the temperature of the object at a given time minus the ambient temperature times E to the decay coefficient, which is represented as K, times T, which is the time. So, first thing we have to do, we have to find K. The way we're going to do that, we use the equation to find K. So, how do we get this all the way here? Well, we know that his temperature at 7:30, which is going to be the temperature of the object, is 80 degrees. This right here, the final temperature, is 75 degrees. So the ambient temperature is 70, plus, we're using 80, since that's his temperature at 7:30, minus the ambient temperature again, E, K, times 0.5. And the reason we use 0.5 is we're measuring everything in hours and not minutes, so we're using half of an hour, so 0.5. So, which we have to get this K by itself. So what we're going to do is we're going to do the natural log so that this E can be cut out. So you have to do the natural log of both sides. So ln of E is equal to 1, so we can cross that out. So this is our decay coefficient, negative 1.290770423. It's important we use the entire number until we have gotten our final answer. Now, we have to find the approximate amount of time passed from death to 7:30 p.m. Once again, we are going to be using Newton's law of cooling. What we're going to be doing differently this time, though, instead of this being the temperature at 8 p.m., we're actually going to use this at 7:30. The temperature of the object will also be 98.6 degrees Fahrenheit. So, our approximate time passed from death to 7:30 p.m. is around 1.6 hours. So, we now have how long it's been since he died. We have now to find the approximate time of death. Approximately 5:45 p.m. So, we have found the value of K, which is the decay coefficient, to be this quite large number. It's a negative because the temperature is getting cooler. We have found the approximate amount of time passed from death to 7:30 p.m. using Newton's law of cooling. Through all of this, we had to find T, which is the time. And this is all in hours. We ended up with 1.6 hours time had passed. And then, the approximate time of death. Subtract 1.6 hours, which is approximately 96 minutes, from 7:30, you get 5:45 p.m.